Hello, I'm Hatter Planetarium Director Ian Clark, and welcome to this edition of Gettysburg Under the Stars, where we will be talking about events in the late December skies 2020. So, perhaps you have heard of the great conjunction of Jupiter and Saturn, the closest appearance of these two planets in our night sky since the 1200s. So let's talk a little bit about how to see it and what to expect when you look up in the sky. Well, here we are in Gettysburg in a grassy field looking to the southwest just after sunset. And there in the distance are the planets Jupiter and Saturn. And as the days go by, they'll be getting a little bit closer together. At December 12th, 6 p.m., going forward in time, a day at a time, you can see the two drawing closer together. 14th, 15th, then on the 16th and 17th, you're going to see a very thin crescent moon. On the 16th, it'll be just below Saturn and Jupiter, and then on the 17th, just above it. The crescent is so thin that it is difficult to see in this screen representation, but you will be able to see it quite clearly in the night sky if the view is unobstructed to the southwest horizon, and of course, weather permitting. The actual date on which those two planets are closest is December the 21st. Right there. And there you can see them almost becoming like one star to the unaided eye. They're actually about 1/10 of a degree apart. For comparison, if you know the star in the handle of the Big Dipper, the double star Mizar and Alcor, which some people use as an eye test, that's about twice as far apart as this will be. They'll be about as hard as 1/5 the apparent diameter of the moon. So these should be within the ability of somebody of average eyesight to be able to tell that it's two objects and not one. But they will be almost touching in the night sky. And once again, that's as close together as anybody has seen these two planets in the last 800 years. So pretty cool. In order to explore what a great conjunction is, let's have a look at this solar system view right here. This is the date, December the 21st, 2020. You can see Jupiter and Saturn lined up on one side of the sun. From the point of view of the Earth, they are almost together in the sky. Looking from Earth, you look in the same direction to see both of those planets. Let's move forward in time and see how long it takes for another one of these great conjunctions to occur. Again, note the year up here as we move along. I'm going to take the marker for the Earth away because the Earth is going to be going by pretty quickly. And then let's move forward in time more slowly at first and then quicker. So Saturn takes about 30 years to go around the sun once. Jupiter, 12 years. So eventually Jupiter is going to catch up and they'll be in line again. See, we're in the 2030s right there. Here it comes. Jupiter's coming closer. And boom, they catch up on late October, early November 2040. These great conjunctions occur about once every 20 years, actually once every 19.6 years. And one thing to note about them is they're not all created quite equal. Now, we've already said this is the closest one since the 1200s. If you're able to wait around for 60 years or so, there will be a very slightly closer one in the year of 2080. I believe it is in March, if you want to put that on your calendar. But the important thing to note here is that Jupiter and Saturn are not close together in three-dimensional space. They are close together in terms of line of sight. Saturn is still in the background, Jupiter is in the foreground. On this particular conjunction, Jupiter is about 900 million kilometers away, whereas Saturn is 1.6 billion kilometers away. Back on Earth, if we look up and to the left away from Jupiter and Saturn, you'll see the one other planet that is visible in the evening sky right now, and that is Mars, shining bright and red and staying up after Jupiter and Saturn have already set. For a tour of the constellations right now, we can also start in the southwest. This is a little bit later. You can see that Jupiter and Saturn have set by this point. Mars is high up in the south, and we can just see the summer triangle before it sets in the west to northwest. That's made up of Altair, Deneb, and Vega, and they stay up in our sky for a long time because they are so far north. And in the northern hemisphere, we see more of the northern part of the sky than we do of the southern. Speaking of the northern part of the sky, I'm spinning around now to look to the north. You will see Ursa Major, the Great Bear, a constellation which contains the Big Dipper. You'll notice that the orientation of the Dipper has changed a bit since the fall. In the fall into late fall, it lies almost horizontal along the northern horizon. And by now, 8 p.m. in the middle of December, it's beginning to turn upward a little bit toward the northeast. That entire constellation, by the way, never sets for those of us at 40 degrees north latitude, and we call that circumpolar. When it is down low like this, Cassiopeia is up high. The North Star is right in between them. Cassiopeia, the queen, quite high in the early evening in December. Turning our attention to the east, we get a real peek at the winter skies there with the full body of the Great Hunter, the constellation Orion, revealed up above the eastern horizon, doing battle with Taurus the Bull. The other thing that we want to talk about, since this is our December show, is the winter solstice. December 21st happens to occur this year at 5:02 a.m., as you'll see a little bit more in the almanac in a few minutes. There's a diagram you're probably used to illustrating our seasons, showing the tilt of the Earth's axis with respect to its orbit around the sun. The size of the Earth here wildly exaggerated in terms of its scale. One interesting thing to look at is another simulation, and that would be looking at the Earth from the perspective of the sun over a year. And you'll see that the southern hemisphere is getting light more directly, and then the northern hemisphere getting light more directly. To see how that looks from Earth's vantage point, we can go to 40 degrees north latitude, Gettysburg or thereabouts, and track the path of the sun. There it is on June 21st, crossing high in the sky, setting to the north of west. On September 21st, the equinox march would be very similar, rising due east, setting due west, taking an arc in the sky that's lower than that in June. And then finally, December 21st, rising to the south of east, setting to the south of west, and taking a very shallow arc in the sky so that the sun shines on us with less direct light, therefore lower in the sky, and it's also not up for as long. We can move around in our vantage point. They're looking to the east, to the south, and to the west. And those are the three paths of the sun that essentially create our seasons. More on the exact times of sunrise and sunset in the almanac in a few minutes. But before we close out here, I want to say something about an upcoming show. James, our student assistant, is preparing a show on sunsets and is inviting members of the Gettysburg College community to submit pictures of sunsets either from Gettysburg or remotely. So if you happen to see this before Monday, December the 14th or thereabouts, drop those to us either via Instagram message, or if you go to our Instagram, you'll see James gives you his email address and you can send them as well. So we look forward to bringing that show to you very shortly.